Hello everyone, come to the talk, come to talk about LSP. So my name is Eric Dallo, I'm Brazilian, I came with the Nubank folks. Today I'll be talking about something that everyone here loves, that is linters. Who doesn't like linters? Yay! So don't you all think that it's cool when your pipeline fails and you can merge your pull requests because of linters? Yeah, that's cool. Or when you're at your editor and he's telling, no, you are coding wrong at your face. So those are things that make your life easy sometimes and not sometimes. So I'll talk about how can you avoid having a lot of linters or having no standard configuration and things like that. So the talk is called Clojure-lsp 1 tool to link them all. It's a strong title, I hope. And I'm talking about how Clojure-lsp could help you with all of that. So I'm a software engineer at Nubank. Came out from Brazil, São Paulo. Those are some tech subjects I really like. I love Emacs. As you can see, I'm using the presentation at Emacs. Don't judge me. I even managed to make the controller work with Emacs. That's awesome. I hope everything goes well. So I really like Linux, especially NixOS, which is a functional operation system. Yay! And I love dev tooling. So most of the projects I work are related to dev tooling because it's the most important thing at a company, the dev happiness, yeah? So those are some open source projects I'm working. There is Clojure-lsp, obviously, there DepSbin, CLJ Easy, and a lot of other Emacs projects for Clojure and Flutter and things like that. So let's start with this beautiful picture of our building at Nubank. So this is our purple building in Nubank at São Paulo, Brazil. If you want to learn more about Nubank, you can scan this QR code or enter this web page. Nubank, it's a huge company. It's funny because my last talk about Clojure-lsp and Nubank, we had half of those numbers, so it's a little bit scary, but awesome. We have 80 million customers, which is a lot of people. We have 1,800 software engineers, which is another lot of people to manage, a lot of people to keep standards and help with 1,800 editors. So we also have 1,300 Clojure microservices. So each of these services are projects, Clojure projects. So as Bruno talked yesterday, we saw that we have lots of standard for things, and linter, it's included there as well. So what we'll cover on this presentation? We'll talk about the problem. Yeah, Joãozinho talked with Sal that the problem is important to discuss. So we'll talk about what was the problem back some years ago. We'll talk about what is this Clojure-lsp, this thing that the kids are using these days with TikTok and things like that. So what is that? How all this stuff is related to linting? Don't know. Let's see. The features that the linting part of Clojure-lsp has that's important. The most important part of the talk, the configuration across different projects and editors, how you can manage one configuration for hundreds, thousands of projects. How we are using all those features at Nubank because we like standards, we like to follow some kind of pattern, and how Clojure-lsp is helping us to achieve that. There is the custom linters that we will talk about. It's a really nice feature we could use. And after all that, when you should use Clojure-lsp all the time, we'll talk about that as well. So let's start with the problem. So back then, when I joined Nubank 2019, we already had a lot of standards already of standards at our services, like code standards and CI and things like that, but there was one thing that was missing, that was the linters, the linter stuff, because it was a completely wasteland, to be honest. If you were working in a project, you could be using CLJ Condo to lint stuff, but then you change to another project using Eastwood, and then another project is using both. Oh, that's probably good, I think. Oh, no. Another project is using no lint at all, so there was no standard, and that make our developers confused, right? So we found that having more lint tools or different tools across the code base means harder to manage, harder to standardize, right? And different tools means different configurations. One tool could lead us to configure in a way, and other way with different defaults. So that was a problem. And how could we answer things like, should we remove new lines on this project, on all projects? Should we apply vertical alignment, warn about the deprecator, or just info to the developer and don't fail the CI at all? How can we manage outdated linter versions in some projects? So even if every project would be using the same linter, different versions could result in different outputs, right? So how can we manage the update of those linters or those configurations? Also, besides all the linter stuff, we have the editors that our developers using. So Nubank, it's a free country. No, Nubank, it's a good place, so we don't ensure people to use the same editor. They could use what they feel comfortable with. So how can we handle different editors like Emacs, VS Code, IntelliJ, Vim, and things like that? So how can we avoid local configurations in the developer machine? Because the linter could output something, and the developer could go to a vacation, and after 1 month, the linter is not telling the same thing. So how can we ensure that is updated and following the same standard, right? So let's start with explaining what is the LSP, right? Because it's important to understand why this project exists and how it's related to lint and then. So some years ago, Microsoft created the LSP, which stands for Language Server Protocol. They were creating the VS Code editor, and they found that was really a messy thing to create, to handle all the programming languages, because they will need to handle JavaScript, Clojure, Java, different ways, and each editor were doing things completely different, and they could have some features and others that other editors didn't have. So the LSP was created to create this standard, to create a protocol. So editors and language servers could follow the same standard, right? So it's basically a paper. It's basically a web page saying what you should do, and what features are mandatory, what features you should implement, like completion of the code, diagnostics showing you squiggles, hover over cursors and things like that. So there's a lot of features, and that's what LSP is. So we have the Clojure-lsp, which is the language server for the Clojure language, and it's open source. So you can just go to GitHub and check the issues, pull requests. You can contribute with Clojure-lsp. I really recommend. You can fund us. You can sponsor us. That would be nice. It's completely made in Clojure, so that's nice, I think, because I could implement a language server for a different language in another language. That exists and could happen. But it's made in Clojure because it's the best language to implement things, right? It's a good opportunity to join the Clojure community. When I joined Nubank, I started contributing with Clojure-lsp, and that helped me a lot to join the Clojure community. That is awesome, a lot of good people there. So it's a good project. We have the good first issues to people that want to contribute, want to join this wonderful world. So I really recommend join there. So how all this editor thing is related to linting, right? So Clojure-lsp has a lot of features, so already knows how to handle project search paths, class path of your project, the analysis of your project. So there was this idea some years ago to provide all those things via REPL. It's interesting. We didn't. Some people don't know about that, but language server runs outside of your editor. It's a process that editor just spawns and keeps running under the hood. So it's really not related with REPL. It's not related with runtime stuff. It's all about static analysis. But the idea was really cool and makes sense. So after a lot of hammock time and discussions, we managed to make that work and delivered all those cool features via different ways, different entry points, right? So Clojure-lsp already knows your project class path, like I said. So already knows how your project behaves, already knows all the search paths it should seek for different projects, lining in depth, shadow, and lots of different projects. It uses CLJ Condo under the hood for diagnostic stuff, so, and analysis, which it's important for most features. So we use CLJ Condo to analyze the project, and we take actions based on those analyses. It uses CLJ FMT for the formatting stuff, so everything related to format spaces, new lines comes from there. Also, it has the logic to clean the namespace and do lots of refactorings, like moving functions there, cycle some private software function. There is a lot of refactoring. So we already have all this stuff, but we are just delivering to the editor. We could deliver to another entry point, right? Why not provide all those features via an API, via a command line interface? Because that is possible. We already did the hard stuff, you know? So I will talk about the main features after we implemented all those layers and complex things. And these are the main features of the Clojure-lsp API part. So we have the diagnostics. Diagnostics is probably pretty similar to the CLJ Condo using via the command line, because it provides all the findings of the project, like unused vars, unused code, redundant code, and things like that. We do have another upstream, another source of diagnostics, like CLJ depend, to ensure we are using some kind of layer definition. So you could define that a namespace ending with this suffix could not call another namespace, but this namespace could call other namespace. So you can limit the namespace relationship, right? So that comes from CLJ depend. We have also other built-in linters like the unused public vars, because we do know your project. So you do know all the relations of your code. So you could say that that var is unused, but that one is used by another search path or another place. So that's how it looks in the editor. So you could see the yellow squiggle out there. And that's how it looks, the same output from the command line interface. So it's the same thing, but in a different way of entry point. Then we have the clean namespace. Clean namespace is also a really good feature. It can fix or just report the unused or unsorted requires, imports, alias, refers, and everything like that. So say we have this namespace with unsorted requires, unused requires, and imports, and after applying this clean namespace, you would have this beautiful namespace. And this is the same thing, but calling from the command line. You can say that there is this --dry option, which is telling to not change anything, just report. So you could fail a pipeline or a CI or something like that. We have format, which is pretty simple, pretty straightforward. It can fix or report the files using CLJ-FMT. So before you have this messy code with a lot of spaces and new line and things like that. So after applying the format, we have this beautiful full function. And the same thing from the command line. It's just like the clean namespace. And recently, we added this new feature called dump, which is a feature that, since Clojure-lsp knows all those things, it would be nice to just tell you what are those things. So it returns all the analysis of your project, the dependency graph, all the class path, the search path, things that you can query about it. So here we are using the dump feature and then passing to jet to query the depth graph only. And we can see we have the relation between that my namespace and the Clojure core being required. So you could, what you could do with that? You could, for example, say you have a lot of projects, and after each merge of a pull request, you could run the dump feature and send this information to via an ETL process, to a data lake or something like that, and then you could understand all the projects and different code bases, how they behave, how they are using your common libraries. If there's anything you could improve in the code, if there's anything you could enhance or avoid some kind of standard. So this helps keep standards in your code base, right? So that's a cool feature as well. All right, so how can I use Clojure-lsp via all these entry points? So you have the API, like the issue. We close the issue, yay. So we have this namespace, so you can access all those features mentioned before. You can use via the command line interface. --help will bring all the important stuff that you need to check. You could use via a CI, right? Because now we have the command line. We have a way to run outside the editor. So now you can use, for example, the GitHub action setup Clojure-lsp to use in your projects and fail the pipeline running diagnostics, clean namespace, formatting, things like that. We do have the lining plugin. That is what Nubank is mostly using. So it's just a plugin wrapping the Clojure-lsp, so you could have alias, different alias to fix, or just lint, and things like that. And we have Babashka. Yay, Babashka. So we have this Babashka pod, so you could use Clojure-lsp from a Babashka code. So Babashka code is basically a code that doesn't use the JVM. So with a Babashka pod, you could use external libraries that need some hacky ways to make everything work. So Clojure-lsp has this pod, so you could use from Babashka code as well. All right, so let's talk about this feature, the exportable configurations. So this is the thing that keeps everything together, that make you declare some configuration somewhere and use across hundreds of servers. So CLJ-Condo already has this feature, and it basically searches the class path. So say you are linting a jar file, it will search for this class path. It's a specific path. So CLJ-Condo.export/whatever, which is just for avoid clashes and things like that. So your organization, your library, and it will copy, after passing a specific flag, all the configurations inside that folder to a local folder, so you could use the lint considering all these things. So Clojure-lsp does the same. It was inspired by CLJ-Condo, but it doesn't copy, it just considers it during the LSP usage. So that actually fixed the issue of we have a library and we have a lot of clients using this library, but I want to declare a specific way to lint some macro or some function, and then all the clients could use that lint configuration. So that's really good. Let's see a real example to make it clear. So say we have this macro. Macros are nice, but macros are magic as well. So what happens when you declare a custom macro that should behave similar to a Clojure function? You face this squiggle. Oh no, how can we fix that? We can see that the format is wrong as well. The commas are really close to the var definition, but not following the same standards. So the editor and Clojure-lsp doesn't know that it knows that it's a macro, but it doesn't know how it should lint that macro, how should behave that macro, right? So how can we add a configuration for that library and all the clients could use? So we could have a configuration that will be exported. So we declare it at this specific path, and we are using linter from CLJ-Condo. So we are basically saying, oh, lint this macro like a Clojure function, and that's it. So CLJ-Condo will consider that macro usage as a function, and we are doing the same for a Clojure-lsp export because that's a format configuration. And we want to say to format like a function, right? But there comes code style. Code style is how we are using at Nubank. It's another library. Oh, another library, but it's a dev-only library. It's a library that we use only the dev profile. It's basically a single place where we centralize all those configurations. So after we did all these things, we still need to tell CLJ-Condo and Clojure-lsp to consider those exported things. So that's why we have the config paths. So the config paths are saying, if CLJ-Condo or Clojure-lsp exports this configuration, consider it during my lint usage. So there you could have lots of libraries, lots of configurations, and we are using code style as a single place to centralize all those libraries and the place to define things that should apply to all libraries. So if a library should be linted and deprecated should just info, we could configure that. So things that apply to whole Nubank libraries, right? And the same thing for Clojure-lsp, just using the class path because it will consider only during the class path scan. It's pretty similar. So, and that is the only thing that all the hundreds of services needs. It's actually 2 lines of code. Actually, the service template we have already adds those lines, so people doesn't even need to add that. That is telling to just consider code style, because code style is in the class path that is using other libraries. So the service could use all that configuration for free. And we have the CLJ-Condo configuration, the LSP configuration. So after that, using code style, we have properly linted our macros. So we now have a properly formatted it, and we have no squiggles, which is good. We actually have another feature. We have the code lanes on the right of the feature that is an LSP feature that shows all the reference of the function that are being used across your project. And that happens because we linted that feature as a Clojure function. And a Clojure function defines a var under the hood. So now Clojure-lsp understands that as a function. That's really important for things like reframe and things that define symbols over your project, not following the Clojure functions or macros, right? So it's something that really helps the developer. All right, so this is a summary. So code style really goes into a dev profile. It doesn't go to production. But even so, it's just a simple jar with only export configurations and no code at all. And that's how it works. So your service are using code style in the class path and other libraries in the class path. So it's all available via the class path. All right, so we have now this single place to configure everything. That's really cool, but we're still having the library updates, right? Because Clojure-lsp is really evolving all the time, CLJ-Condo as well, and we have new linters and new ways, new defaults even. So how can we manage the library updates? At Nubank, we found that we could not fix that problem, but mitigate and improve a lot with Bumpito. Bumpito is our bot that bumps the libraries each week. So every week we have Bumpito running in our services, checking all the library code, and open pull requests to Teams review. So it opens the pull request, it shows the change log if there's any breaking change, it tells you, and even runs the lint, because lint could be changed, right? So it runs the lint to make sure that everything is OK. That's Bumpito. All right, so custom linters. That's a thing that people usually ask me, how can I lint my code in a different way to avoid specific problems? Because we have a huge code base, so crashes happen eventually. So how can we avoid specific code going to production that we know that we can't really create a test to get that, like strings and things like that? So I'll show you an example of that. So that's something that happened with us, a crash. So that's a screen from our app. And back there on 2021, a customer was transferred the money at the date. And we are showing that the date of the transfer was 1 year from that date. So that doesn't really look correct. So why that was happening? After a lot of debugging, we found this crazy thing about Java, yay. So Java introduced this new pattern for the date pattern. And so there was the lowercase y, and now we have the uppercase y. And that's not clear what should use, right? And the difference is that the uppercase y that Java introduced, it counts all the weeks of the year. And eventually, and the impossible happens every time at Nubank, eventually you have some year with 52 weeks or 53 weeks. And then we have a wrong year at our app. So we found those kind of things because that's one kind of crash we had, but we had lots of crashes similar to that, where the code was not really wrong. We are using the date format, but we are using a specific string, and we can ensure that the developer will know that because it's just a string. He'll probably check in the test that is using the uppercase y, because the person doesn't know that. So we found there's a specific need of lint your code in a specific way. And there is this feature from CLJ-Condo, there is the hooks feature. So the hooks is basically a way of declaring how a macro should be properly linked, because on that example, it was pretty easy to link that as a Clojure function, but you could have complex macros that you need a hook to tell CLJ-Condo, which is an awesome feature of CLJ-Condo. And there is this specific feature that I don't think everyone knows, but it's a really cool feature called reg finding, where you can, inside your hook, register a finding in your code when you are linting that macro. So let's try to fix that issue. We have the date library. So we have this hook configuration from CLJ-Condo. And it's basically saying to parse that date in a different way. And actually, it works. The hooks of CLJ-Condo works with function. I don't think if that's intentional, but it's really working with not only macros, but function as well. And we declared this new linter, avoid uppercase year notation. And we are saying it's a warning. But where we are defining that. So in the rook definition, we have this code calling the reg finding and saying that we have this specific message, and this is the name of the linter. And boom, we have a custom linter now. when CLJ linked this function, and we did a specific check using CLJ analysis to check if the string had the uppercase Y, we could just call this function when we found that. So that's how it looks in your editor or in your CI, in your lint usage. We are telling the developer to avoid use that code. We are even telling to follow that link and check why we don't want to use that code. So that was an awesome feature that we included, and no crashes like that would happen again, right? Yeah, and this is another example. So we have a lot of custom linters. That's another example because we use a schema from Plumatic to guarantee inputs and outputs following a specific schema. And actually, when you are developing the unit test of schemas, you need to call this specific function. There are lots of ways to do that, but this specific function checks if everything inside that macro with functional validation will really match the schema you are telling. But it was pretty common to people use the schema with validation outside the dev test. And when you run the test via CIDR or wherever way you use it, you will find that it will run only what is inside the dev test because the dev test under the hood declares a var. It does in a different way. So the with functional validation will be completely ignored for that. And that could lead to a bug in production because if the schema is really wrong, the test won't accuse that. So we implemented this console linter to say that you should use it with schema validation inside the dev test. And then no more crashes like that would happen. So after all of that, all those amazing features, why you should use Clojure-lsp? That's always, no, just kidding. You should use probably when you don't want to handle multiple linters. So it's awesome to have multiple linters, actually. We have a huge community. It's nice to have different options, for sure. But it's cool to have standards as well. And different linters could lead to different configurations and defaults. It's hard to manage that. When you want to link the project, not files or folders, because Clojure-lsp knows the project. It knows how a shadow or depths or lining project behaves and the search paths are available. So it knows how to link your project without anything most of the time when you need to configure specific projects. But when you need consistency across multiple projects, you have hundreds of projects and need consistency of configurations, linters, and things like that. You need consistency across custom linters, right? You created that linter and you want to use across all Nubank code base because that crash could happen anywhere. You need consistency between all or most editors. That's actually a spoiler because Clojure-lsp at the moment runs on most editors, but IntelliJ. But I'm working on a plugin for IntelliJ to run Clojure-lsp, yay. But for now, most editors should do it. And even for IntelliJ users, the lint at the CI will catch the errors. So that's not a big issue. You could use the DEM feature for deep analysis of a project, like I mentioned. So you could study and research all the analysis of your code base, understand how some library is being called, if the interface is being clear to the developer, and things like that. And that's it. Thank you very much. Thank you, Conji and every Clojurians. I would like to thank you, Nubank, all the sponsors, especially Clojures Together, to let me work on this amazing stuff with my friends. The documentation of Clojure-lsp is there on the webpage. I have my slides of Emacs if you want to know how that's done. We have my GitHub and my Twitter website. And that's it. Happy Lynch, everyone.